Hi, pre-calc students. We are going to talk about applications with vectors. So in the first lesson of this unit, we talked about what exactly a vector is, and then also given two vectors, how we can draw a resultant vector and find both the magnitude of that vector and the direction of that vector. So now we're going to be given some application problems, and we're going to figure out what the magnitude and direction are. It's just a little reminder of flying an airplane is something that you can use with vectors. We're going to go into just some reminders. Pythagorean theorem, if you know two sides of a right triangle, you can find the third. Also, if you have a right triangle, you can use SOHCAHTOA. So these are both with right triangles. Then law of sines, law of cosines we use when it's not a right triangle. Law of sines, you have to have a side and its opposite angle. If it's not a right triangle and it doesn't have an angle and opposite side, you have to use law of cosines. So we're going to look at three different situations, okay? So this first one, it says draw and label a diagram to represent a force of 125 pounds being exerted due east and 180 pounds being exerted due north on an object. So first of all, just kind of a reminder of what north, south, east, west looks like. This is north, south, this is east, this is west, okay? So we have 125 pounds going straight east. So 125 pounds is being exerted due east. So we're going east, this is 125, okay? Also, there is a force that is going north. So that is up. And that is 180 pounds going up. All right, so there's two different ways we can do this. We could either do, I could leave it like this, and I could do a resultant vector going like this. But I think most of the time I'm just going to stick to doing the parallelograms. So if I take the two vectors, again, this is 125, and I just slide this 180 over, right? So if I make a parallelogram out of this, I just go tip to tip, 180, same direction. Doesn't matter really where I start, as long as it's the same length and same direction. That's not degrees. So I'm just putting the ends of those together. This is north and east is a right triangle. I'm going to make a parallelogram out of this, and then I'm going to go from the point where the two are connected, and I'm just going to draw in the diagonal, okay? So now I have a right triangle, so now I'm going to put that 180 over there anyway. All right, so now that I have this right triangle here, which I'll kind of outline, and this is the right angle, I want to figure out what degree this is, because this, remember, is the resultant. This is the resultant vector. And so we want to figure out these degrees here. So we're going to, first of all, if I want to find the magnitude, I'm going to do this. I'm going to go, because this is magnitude. You know what? I'm going to call that a different variable. Sorry. Why don't I call that A? Or I could call it M. That would make more sense. So 125 squared plus 180 squared equals M squared. Square these, add them together. I get 48,025. Take the square root. And M was equal to 219.1. So this is the magnitude. So if we're, again, we're doing a, somebody's pushing something this way using a force of 125 pounds, and there's a force going that way, what is the result of those two forces? It's that red line there. That's the force, and the combined force going that direction is 219.1 pounds. All right, now as far as direction, that's when we find x. So if I focus on the angle, remember this is my opposite, this is my hypotenuse, this is my adjacent. Well, I have something in the spot of O and A, so this is a TOA problem. I'm going to say tan of the angle is opposite over adjacent. I'll divide 180 divided by 125. I get 1.44, but I'll add a couple zeros to that. And then I'm going to go second tan in my calculator. And the direction is about 55.2 degrees. All right. This resultant vector, so again, I'm just going to kind of really darken this. This is the resultant vector, and it ends up with this angle x here being 55.2. That's going to 55.2, and that's the direction. It's actually 55.2. We could even say north of east if we wanted to, because that vector is that's how many degrees north of east it's going. But it's also okay just to say 55.2. And then the force is 218.1. All right, so that's if we have a right triangle. I hate to say that's the easy one, but it is kind of the easier one when it's a right triangle. So we're going to look at one here where it says two forces are acting on an object. One force is 50 pounds at an angle of 35 degrees. So I'm just going to draw that one. 50 pounds at an angle of 35 degrees. The other one is 65 pounds at an angle of 15 degrees east of north. So let me go back to this, 35 degrees north of east. So if we start east and we go north, that's where we end up, okay? I'm just gonna, I'll leave it there, I guess. So that's where we end up. It's going, we start east, and if we go 35 degrees in a north direction, that's where we are. Okay, now the next one is 65 pounds east of north. So if we were to start at east, or start north, and we go 15 degrees east, so if I go 15 degrees east, so I'm starting north, going straight up, and I go 15 degrees east, well, what angle do I really have here? I've got a 75-degree angle. Because, you know, if we think of like the unit circle, we want to think of it relative to 0 degrees. So we really have a 35-degree angle and a 75-degree angle, two vectors at those angles. So this one is at 35. This one is really at 75 because it was 15 degrees east of north. Okay, now we're going to put those two together. So this is always a little tricky here. So I'm going to take the end of this one here, 75 degree. I'm going to make it this a little bit. So this is about 75 degrees. I don't know that that was much better than the first time, but so we'll say that's 75 degrees. And by the way, that vector was 65 pounds. So this was 65. Whereas the other one, I'm just going to try to do it in green so we see the difference a little bit better, was 50. So we wrote that as 50 before. So I'm just going to go, okay, this one is about 50. right? And it is 50, and this is 35 degrees. That's 35 degrees right there. Okay, so I'm going to make a parallelogram. So I'm going to try to go parallel to the bottom, parallel to the side there. This isn't very parallel. Okay. The other trick is you kind of want to make it big enough so that you can see your angles so it doesn't get too scrunched. But then the resultant vector, so I'm trying to put the two ends together. So I'm putting that green 50 together with the blue 65. I'm trying to put them together, and this is the resultant vector. That's the resultant vector. And that's what we want to know the magnitude for and the direction. Okay? So I'm going to try to highlight this triangle here. This triangle here is what I have information for, because if that blue vector is 65, what's parallel to it, it's a parallelogram, also has to be 65. Okay, so now if I were going to redraw this triangle, I have 50, I have 65. Well, I also need to know what this angle is here, in between the 50 and the 65. So I need to know what that is right there. So I'm going to find that by kind of going back here. If I can figure out what this little angle is right here, then I can figure out this angle. Let me just say that again. If I can figure out this, because if I look at the whole parallelogram, I can figure out what this angle is. So this, remember, was, the first angle was 75, like this angle here is 75. I'm laughing because it's kind of crowded. If I minus this, which is 35, I get 40. So this whole part of the parallelogram, that is 40. Now if I go 180 minus 40, that means this has to be 140. So if I'm looking at this as a parallelogram, like this is 40, down here is 40, and this is 140. So I need to find out this angle here is what I need to find out, that part of the parallelogram. I did 75 minus 35 to figure out that's 40. And then that helps me find this 140 right here. And if I can find that, remember where the resultant is. This is right here. This is our resultant. This is what I'm trying to find the length of, which is the same as the magnitude. And I'm trying to find the direction. Okay, so for the magnitude then, I'm going to go x squared equals 50 squared plus 65 squared minus 2 times 50 times 65 times cosine of 140. Oops, into a triangle there. And I can put this whole thing in the calculator. By the whole thing, I mean this whole side. And just put the whole thing, especially if it's a graphing calculator. I'll get 11,704.3. We'll take the square root of both sides, and we get 108.2. So that is our magnitude. Let's go ahead and say pounds. So that is our magnitude. Now the direction, so if you look at the direction, let's kind of go back to this triangle here. The direction we're looking for is now this piece here, if I can get the right color. Maybe I'll do it in yellow. This is the direction right here. we're trying to figure out how big this angle is from the ground. I know that this here, I know this is 35, right? I know that that was 35, if you remember that from before. I'll try to stick it back in there. That's 35. So if I figure out this little piece here, maybe I'll call it y, which is the same as this, then I just have to take that y plus 35 and it'll give me the direction of that pink arrow. So I need to find that y. So if I look at my picture here, now that I know instead of x, I know that x is 108.5. X is, maybe I'll turn this around so x is 108.5. But now for the direction, I can use the law of sines because I can go angle over side equals angle over side. Sine of y, let's go ahead and go sine of 140. Sine of 140 over its opposite side. It doesn't matter, but. And then sine of the angle over its opposite side. We'll go ahead and cross multiply. So this times this times this. So sine of y equals, 108.5 times sine of y equals 65 times the sine of 140. I'm going to divide both sides by 108.5. 108.5. I get about 0.3851. I'm going to hit second sin of that, and I get 22.6. Okay, so remember then, that's not really my direction, but it's almost my direction. Because like I said before, I'm going to add that 35 degrees that got me to that green line, plus that 22.6, and the direction is 57.6 degrees. I could, again, that's 0. So if we kind of go back and look at this, I mean, this is considered 0, but this 35 plus what we just found with that y, 35 plus 22.6, that is the direction here. That's how far that is. And you can say north of east, but if we, remember that it's thinking of the unit circle where 0 is, that is our direction. Okay. One last one. Okay, so 2 tow trucks are pulling on a truck stuck in the mud. Tow truck number 1 is pulling with a force of 635 pounds at an angle of 51 degrees. So, I mean, I can draw them separate, but I can also just try to draw them together. Maybe black is the wrong color to choose, just because I'm going to be overlapping here. So 51 degrees, something like this, and it's 635 pounds. All right. Now the second one is going at a force of 592 degrees, 39 from the horizontal. So this here, this degree, was 51. And now we have another one that is 35. I just lost that place. 51, 592 at 39. So 592 that is 39 degrees right there. Okay? So I'm going to draw my parallelogram. So I guess I try to go like this. Does that look parallel to the bottom? So basically, if this is 592, the black one above there is 592. If this is 635, this is 635, something like that. Okay. And our resultant vector starts here and ends there. So that it's that pink line that I want to, figure out what is the resultant vector, and then I want to figure out what this direction is. From, if this is 0 degrees, how far from 0 it is. Okay, so I'm going to start it with the magnitude. I'm going to redraw this triangle again. So maybe I'll try to do it in the same colors where this is, just so we can see, this is the X, this is the 592, and this is the 635. And what we want to know, first of all, is we want to know what the angle is in between 592 and 635. Well, I know if I go, the green is 57, and if I minus, 51, and if I minus 39, I'm left with 12 degrees. So basically this angle here is 12, right? This is 12, same here. This is 12 degrees. So 180 minus 12 is going to be 168. So this is 168. This is 168. And now that I have an angle in between two sides, I can find the magnitude. So I'm going to go x squared equals 592 squared plus 635 squared minus 2 times 592, 635 times the cosine of 168. Okay? Bring this down a little bit. Okay, so we calculate that. I put this whole thing in the calculator, and we should get a big number. We'll take the square root. And that resultant vector now has a magnitude of 1,220.3 pounds. So the two trucks together, they're pulling two different directions, and this is the result. They're going two different directions. This is the new direction here, and the combined force, you don't just add the forces together, it's a combined force because they're going two different directions with those forces, but the combined force ends up being 1,220.3 pounds. And now that we know what that is, the direction, kind of similar to the last one, the direction is that red 39 degrees, because look at this is the resultant right there. It's that red 39 degrees plus, I'm going to call it y right there. So if I add 39 plus y, so I'm really looking for that, back to that original triangle. So in order to do that, I'm going to use law of sines. Law of sines. So I'm going to do angle. So angle, let's see, I can say the sine of the angle y over 635 equals sine of the angle over 1,220.3, and we'll cross multiply. So 120.3, so I'm cross multiplying. I divide both sides by this. So when I put 653 times sine of 168, hit enter, divide by 1,220.3, and I do second sin of that answer, I get about 6.1 degrees, okay? Which seems like it makes sense. You know, again, going back to this picture, I mean, if I got 66.1%, that wouldn't make much sense. But it's 39 plus this little y angle there. So 39 plus y. So if I go back to 39 degrees plus y, and 39 degrees plus 6.1, I get 45.1 degrees. A little bit better there. And I can either leave it at that, or I can say north of east. But if we say 45.1 degrees, we know it's relative to 0. Okay, so that again, it was so long ago that we said direction, but that is the direction of the force that results from two trucks that are moving they're pulling from two different directions with two different forces. So the result of those two trucks is a force that's going in the direction of 45.1 degrees and is giving a force of about 1,220.3.